Okay, we're going to finish up this chapter with a triangle inequality theorem and inequalities involving two different triangles. So let's see what the triangle inequality theorem has to say. It says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we know that there's three sides to a triangle. So what this is saying is if you add up any two sides, it has to be greater than the third side. So here's an example. If we have this triangle and we take these two sides, they have to add up to a number bigger than the third side. What is 6 plus 7? It's 13. Is 13 bigger than 10? Yes. Then we check the other pairs of sides. If we do 6 and 10, we get 16, and that is greater than 7. And then we do the other pair of sides, which is 7 and 10, gives us 17, which is also bigger than 6. So according to this theorem, any pair of sides that you add up has to equal more than the other side. Okay, so our inequality could look like this. We would say side AB plus side BC is going to be bigger than side AC, according to this theorem. That has to be true for all types of triangles. Another inequality is called the side angle side inequality, also known as the hinge theorem. And let's see what it says. It's pretty wordy, but we'll draw a picture so you can understand it a little bit better. This one is comparing two different triangles, and it says if two sides of one triangle are congruent to two sides of another triangle, and the included angle in one triangle is greater than the included angle in the other triangle, then the third side of the first triangle is longer than the third side of the second triangle. So we have two triangles where the sides are the same, they're congruent, but if the included angle in one triangle is greater than the included angle of the other triangle, then this third side is going to be bigger than the third side of the second triangle, is basically what this is saying. Here's another picture. So we have two triangles. Two of the sides are congruent here. Two other corresponding sides are congruent, but the angle in between those two sides is different. This one is smaller than this one down here. Therefore, this third side is going to be smaller than this third side. Or you could say this third side is greater than AC. We could write it two different ways, write our inequality. I can say DF is bigger, or I can say AC is smaller. It doesn't matter which way you write it. Okay, again, thinking of a pair of scissors, that makes sense. I'm creating triangles with my scissors as I open them up. The more I open it up, the longer that distance is between the two blades of the scissors. Another inequality is the side-side-side inequality. Let's see what it says. Obviously having to deal with all three sides, just like the last one was side angle side, and we dealt with two sides and their included angle. This one says, again, we're comparing two different triangles. If two sides of one triangle are congruent to two sides of another triangle, and the third side of one triangle is longer than the third side of the other, then the angle between the pair of congruent sides in the first triangle is greater than the corresponding angle in the second. So this is backwards from what we just learned. Let's look at a picture here. Here we have two pairs of corresponding sides congruent to each other. And the third side is different. So that means these included angles are going to be different. Which one is the smaller one? Angle B or angle E? Well, in order to figure that out, we're going to look at these measures. The smaller side is going to create the smaller opposite angle. The bigger side is going to create a bigger opposite angle. So again, we can have an inequality statement one of two ways. We could say angle E is bigger than angle B, or we can say angle B is less than angle E. Either way is acceptable. Okay, so you just need to know these relationships and be able to predict. Let's do some examples. Determine whether the measures 6.5, 6.5, and 14.5 can be lengths of the sides of a triangle. Well, we said that the sum of any pair of sides of a triangle has to be greater than the third side. So let's take the 6.5 and the 6.5 and let's add those together. 6.5 plus 6.5 is 13. Is that greater than this third side? No, it's not. So right there we know that our answer is no. Okay, we don't have to keep going. But if we had a yes here, we would have to keep going and pair up all the possibilities to see if we got a yes for all of them. Here's another example. Triangle PQR. If PQ is 7.5, QR is 7.2, QR is 5.2, which measure cannot be PR? Okay, well, PR has to be less than the sum of these two sides. So we have 7.2 plus 5.2 gives me 12.4. Okay. So this sum has to be bigger than PR. Well, it's bigger than 7. It's bigger than 9. It's bigger than 11. The only one that it's not bigger than is 13. So PR cannot be 13. Choice D. Let me use a better color here. Okay, so here we have triangle XYZ. We know that XY is 6. You can draw it in here. Might help you visualize a little bit better. YZ is 9. Which measure cannot be XZ? Well, again, we're going to add the two that we have, and that has to be bigger than the third side. So the third side has to be less than 15. The only answer that is not less than 15 is answer choice D. Write an inequality relating angle LDM, which is this angle right here, to angle MDN, this angle right here, using the information in the figure. Okay, so we know that this left triangle has a side of 12, and so does the right triangle. And they share this side. So they have two sides that are the same. So we need to compare the third side. Is 18 bigger or smaller than 16? It is bigger. So is 141 going to be bigger or less than 9a plus 15? It's going to be bigger. So 141 is greater than 9a plus 15. Okay, that would be one way to write that inequality, and we can solve that just like we would if that were an equal sign. Okay, so I'm going to borrow here. That becomes a 3. Because we're dividing by a positive number, then we keep our sign the same. Remember, if we divide or multiply by a negative, then we have to flip our sign. Okay, so A is going to equal 14. Right, so as long we have to have two sides that are the same in order to compare that third side in a triangle. Third example. Doctors use a straight leg raising test to determine the amount of pain felt in a person's back. The patient lies flat on the examining table, and the doctor raises each leg until the patient experiences pain in the back area. Knighton can tolerate the doctor raising his right leg 35 degrees and his left leg 65 degrees from the table. Which foot can Knighton raise higher above the table? Well, because the angle measure here affects the distance here, we can kind of draw it something like this. This would be the 65, and this would be the 35. The distance that the 65-degree angle creates is greater than the distance the 35-degree angle creates. So it would be his left leg. Okay, this one's going to be a little time consuming, but you need to understand how to compare things in coordinate geometry. So we have a triangle, and we have the vertices of our triangle given to us, the coordinates of them. So we need to know if this can really make a triangle, if they would meet. So we got to compare the lengths. We need to do, I've got to change my ink color again. We've got to compare the length of AB to the length of BC and the length of AC, because I got to be able to add any of these two up, and it's got to be greater than the third side. So first of all, we're going to have to find our distances. So our distance formula, remember we subtract our x's, we subtract our y's, square them, and add that together. So I've got to choose for AB, y2 minus y1 equals x2 minus x1. That's where these numbers came from. Now when I do the math, I subtract a negative, that becomes a positive. So 1 plus 2 is 3. Negative 2 plus 2 is 0. 3 squared is 9 plus 0. Square root of 9 is 3. So the distance between point A and point B is 3. Now let's do the distance between A and C. Again, we're going to say y2 minus y1 squared plus x2 minus x1 squared. So we're going to fill in these numbers. Again, subtracting a negative here gives us a positive. Subtracting a negative gives us a positive. Negative 2 plus 2 is 0. 2 plus 2 is 4. This goes away, just like this did up here, because 0 is nothing. 4 squared is 16, and then don't forget we're taking the square root of that, so we get a 4. Now we need to do the length of BC. Again, y2 minus y1, x2 minus x1, negative 2 minus 1 is negative 3. Here we're going to subtract a negative. That becomes a positive, so that's 4. Okay, so what is negative 3 squared? Negative 3 times negative 3 is a positive 9. 4 times 4 is 16. 9 plus 16 is 25. And we're taking the square root of that. So we get a 5 here. So our three lengths, AB is 3, AC is 4, BC is 5. Now we have to compare the sum of two of these to the third side. So is 3 plus 4 bigger than 5? Yes. Is 4 plus 5 bigger than 3? Yes. Is 5 plus 3 bigger than 4? Yes. If we say yes to all three of these, then yes, this can be a triangle. If any of these is no, your answer, you stop and your answer is no. So this is an example of a coordinate geometry problem where you're actually given the coordinates and having to determine your distances. It takes some time, but you need to be able to do it. Okay, here's some others. Determine the relationship between the lengths of the given sides. Okay, so SR and ZS. SR and ZS. Okay, well, we need to know this third angle here in order to compare the sides because it's opposite of the ZS. How are we going to find this third angle? What do we know about the three angles of a triangle? Hopefully you said they add up to 180. So if I take 43 plus 97 plus something, that's going to equal 180. Well, this is 140. So what is x going to be? X equals 40. Okay, now I can compare the sides opposite these angles. Which is bigger, 43 or 40? Obviously 43 is, so its side, SR, is going to be bigger than ZS. Again, just do it in the order that they're given to you. So I could just say SR is greater than ZS. Now let's compare ZY here to RZ. ZY to RZ. Again, we're going to have to find this third angle. No, we don't. Do we need that? Y? Nope, we don't need that. Okay, so wait a minute. ZY, yes we do. No, we don't. Yes we do. No, we don't. Yes we do. No, we don't. Do we? Do we need to know this third angle? ZY is opposite 45. RZ is opposite 95. So ZY is going to be smaller or shorter because its opposite angle is smaller. So ZY is less than RZ. And then the last one is TY and ZT. Okay, ZT is opposite the 66, but TY is opposite this one right here. So we got to do some figuring. We have 91 plus 66 plus that missing angle is going to equal 180. Okay, so 157 plus something equals 180. X is going to equal 23. So you can put that in there for reference sake. Well, TY is going to be significantly shorter than ZT because its opposite angle is smaller than the 66. So TY is less than, put a line segment over that, ZT. So there's an example of how to compare side lengths. Let's compare some angles here. Determine the relationship between the measures of the given angles. So WXY, I mark it, and XYW. Okay, again, so I'm going to go across and hit 14. I'm going to go across and hit 12. So this angle is going to be bigger because its opposite side is longer. So WXY is bigger. So I'm just going to put a greater than sign in here instead of writing it all out. Okay, now let's do XZY. XZY here, and XYZ. Again, let's go across. We hit 15. Go across and we hit 18. Well, 15, that's going to be smaller. So XZY is smaller. So I'm going to put a less than sign there. And the last one, WYX. WYX here. And XWY. XWY. Okay, so I go across and I hit 12. I go across and I hit 15. So my first one, WYX, is smaller. So I do a less than sign there. So there's an example on how to compare your angles. When you know all three sides, you could put all three angles in ascending or descending order. You could compare all three of them. And vice versa. If you know all three angles, you could compare all three sides and put them in either ascending or descending order. All right, so know how to compare angles and sides within a triangle or comparing two different triangles.